Alright, for this problem we're looking at different ways to do reductive amination. So you want to think about where you can make your molecule breaks. So if I do it for this one, and the other half is the amine, I start with a carbonyl here, plus NH2, and the rest of the molecule. And then you'd have to add that with sodium cyanoborohydride. And you can also break it on this side, where you would use that, plus the other half is the carbonyl, plus NaBH3CN. For this molecule, you would have a break there. Or you could do a break there. So those would be the two possibilities there. Here we're looking at drawing structures. I have a cyclopropylamine as the parent. So I have an N with a cyclopropyl coming off of it, and then NN dimethyl would just be that, two methyl groups. Benzoylamine has a benzylic carbon, and then the NH2 here. Alright, consider the structure of LSD, which is a hallucinogen with 3 nitrogen atoms. One of the 3 nitrogen atoms is more basic than the other 2. Which one is the most basic? The most basic one will have the most number of alkyl groups on it. So this one right here is the most basic. This would be the next because there's 2 alkyl groups and a hydrogen. This one is the least because there's an electron withdrawing group on there. Alright, here we're drawing products of aniline with the following. You have excess Br2. That is going to brominate at all of the ortho positions plus the para. With excess methyl iodide, we will methylate. Now we're making all these from hexanol. I need to make hexylamine. So I'm going to make this into a Br. Actually, I will use PBr3 to do that. NaN3 followed by H2PD, and that should get me my target molecule. If I want to make heptylamine, I'm adding a carbon. So I use PBr3 again. NaCN. And then excess LAH. H2 will give me my target molecule. Pentylamine, so I'm losing a carbon. do elimination, ozonolysis. Get the aldehyde, and then do a reductive amination. I have nitrobenzene, and I need to make para-chloroaniline. So I can't put the chloro on right now because it is a meta-director. So I need to make it into the para-director, which is the amine. So I can reduce this using zinc, HCl, and now I have an ortho-para director, but it's also very activated and could chlorinate many times. So I'm going to use acetic anhydride to make it less active. Add my chlorine. And get the target. Oops, then I have to hydrolyze that. So H plus and water to get the amine back. Using acetic acid as our only source of carbon, we need to make N-ethyl acetamide. So my strategy for this one is I want to have an amine, and then I can react it with an acid chloride or acetic anhydride in order to add that. I guess I have to use acetic acid, but the acid chloride would be the most logical one here. So I'm going to make the amine first by reacting it with, let's say I'll make the acid chloride, then I can use it again later. Alright, so this will be intermediate A, acid chloride, and then I'm going to add ammonia to make the amide, which I can reduce with excess lithium aluminum hydride. And then now I can react it with the acid chloride that I made earlier to get my target molecule. Alright, here I can draw the major product expected when I would treat this with methyl iodide and silver oxide. So N and dimethyl 1-phenyl-propan-2-amine. So propan-2-amine, there's a phenyl group at 1, and I have methyl groups on my N. So I'm going to react this with excess methyl iodide. And we're going for the least substituted alkene here. So we'll get that one right there. Alright, so a major product with the HONO reaction. This is a secondary amine, so we're going to form the N-nitroso compound there. Synthesizing this Br2. So this Br right here is disguised as an NH2. So that's how you can think about that one. I can add one Br right now because this is a nitro group with a meta-director. So I'll use Br2 and FeBr3. And then I have to reduce that, so I can use tin and H+. Use the HONO. Copper bromide will get me to my target molecule. Alright, for this synthesis, I need to add a group that is meta, an alcohol that is meta to this alkyl group here. So ways that we've done alcohols is with a bromine, but has to have a ortho-para electron withdrawing group, which we don't have. This is meta here. So I think we should go about this using the N2 here. And that is meta. So in this case, we actually need to add, we can do our carbon group first. And I can, to avoid a rearrangement, just add this and then reduce it. This one is a meta director, so actually I can add my nitro group right now. And you can use iron and acid to reduce my nitro group. That should leave my carbonyl alone. React it with HONO. And whoops, I need to reduce my carbonyl. Actually, all right, we're going to go this way instead. So I'm going to reduce my carbonyl here with zinc amalgam. Then do the HONO. And then I can react that with water to get to the desired product. All right, here we're going for a para-chlorofluorobenzene. And fluorine we can only add using HONO, or the azide compound. So chlorine is an ortho-para director, so I'm going to add that one first. Add my nitro group. Reduce that. Make the azide. And then add HbF4. Alright, here we're drawing major products. We're going to react with excess methyl iodide. Followed by silver oxide, and then we're going to do an elimination with that.
Did you forget to record?
So we'll get that double bond there. All right, major products here, nitro group with benzene, bromobenzene. We're just going to reduce that nitro group with that iron. If I react B together, so aniline plus the ketone, this is a reductive amination. I'll get that product. That's the carbon right there. And then for lithium aluminum hydride, we're just going to reduce that amide to the amine. All right, that's the problem that we just did. All right, meta-Bromoaniline. Is treated with the diazonium salt, and then each of the following. So the diazonium is just going to make the N2 where the aniline is. Reacting it with HBF4 is going to give us a fluorine there. And then reacting it with copper nitrile is going to give us a CN. Draw the expected product. So here the nitrogen is going to react with this carbonyl here. So if I look at my 5-membered ring, there's 1, 2, 4 carbons plus a nitrogen that will connect to that. So I have a new bond right here. 1, 2, 3, 4. And that's the nitrogen. Plus the H here. So if you wanted to redraw that, look like that. All right, so we need to synthesize this starting with benzene and any reagents with 3 or fewer carbons. So I'm going to start with, if I do a disconnect here, I could come from there plus aniline and do a reductive amination. So those are the 2 pieces that I need to make. So I'm going to start with the aniline. That one will be pretty quick. This is HNO3. And just reduce that. So there's one part, and then I need to make benzaldehyde. And then I can add those 2 together with sodium borohydride. All right, again, we're starting with benzene and 2 or fewer reagents. So if I'm going to do my retro, I have benzene. Plus here, I'll need to make an acid chloride. So again, I'll start with aniline. And then to make my benzoyl chloride, do a Friedel-Crafts. I'm going to oxidize it. And then convert it to the acid chloride. And then you can stir those two together to get your target molecule.